Hi, my name is Colin Daniel. In this video, I'm going to introduce you to what we call the simplified version of the Caribou Cumulative Effects model. This video is the fourth in a series that we developed, the first of which gives you some of the conceptual background behind the model. Second guides you through sort of a technical installation of the actual software. The third video introduces you to the full version of the software, and in this video we'll show you the simplified version. The second and third videos are kind of optional going into this one, but the first one is pretty helpful as background. It's only about 7 minutes long, so I do suggest you take a look at it if you have a chance before going on with this one. Just a quick overview of that first video. The Caribou Cumulative Effects model, it's a simulation model. It takes a number of different inputs regarding past and future state of a caribou herd, information like past caribou locations, projected future vegetation, levels of development, information about population size and future harvest levels. And what's kind of unique about the CCE is that it integrates 3 different submodels to try and make projections about the effects of these different model inputs on different key indicators. So the first of these submodels is a movement model, and it basically projects future movement patterns of caribou as well as the future pattern of industrial development on the landscape. The outputs of this submodel are fed into a second model called the body condition model, and its purpose is then to project changes in body condition of caribou over time in response to changes in its environment. And finally, based on these projections in body condition, a third model then uses these along with assumptions about caribou population and harvest to project the fate of the caribou population herd over time. And again, there's more detail on all of this in the first video. So we've developed 2 different versions of software to interact with this model. The first of these is what we call the full version, and it provides access to all of the model inputs and makes projections of a wide range of model outputs. However, we've also developed a second version of an interface on the same model, which is the one I'm outlining here, and its purpose is really to make it much simpler to game with key management decisions on the landscape. And so here we focus in the simplified version on projecting changes in population in response to varying assumptions regarding future caribou harvest. And so I'll demonstrate the link between those models in a minute. So in the second video, if you followed it, you would have ended that video with 2 shortcuts on your desktop. One is a shortcut to the full version of the CCE, and a second is a shortcut to what we call the CCE Lite, which is this simplified version. So if I just fire up the full version to start, and this again was demonstrated in more detail in the third video, you can see here we get an interface, and I can, from this interface, I can select what we call a model library. And in that library, if I open it up, I get a complete list of all my model inputs and outputs for different scenarios that I've run in the past. And in this example here, in this demonstration library, we show, for example, 3 different what-if scenarios that we've run through the model. The first of these is a scenario in which we assume current development continues into the future. Second one in which we add to that assumptions regarding increased development over time, but again with no harvest in both of these, and a third scenario in which we assume the future will have increased development and a particular harvest level, in this case 2,000 animals per year. And this demonstration database is all developed using a herd in the Arctic of Canada, tundra caribou herd called the Bathurst caribou herd. So we went through more detail on how these scenarios are developed in the previous video, but just very briefly, if I take one of these scenarios, I right-click and I open it, I can see the details behind that scenario in this full version of the software. And I won't go into the details, but as we showed prior, we have, let's just scroll back here. Here we have 3 different versions, 3 different submodels, I should say. And so we correspondingly, in the full version of the software, provide you with access to the model inputs for each of these submodels. For example, here are some of the inputs for the movement model. Here's a quite extensive list of inputs required for the body condition or energy protein model, and then finally a suite of inputs required and specified for the population model. And so, for example, here on the population model, we're telling the model that we're running it from the year 2020 to 2040, and because this model is stochastic, we're going to repeat the runs 50 times to get some idea of the uncertainty in our projections. And we also had to specify a number of demographic parameters to run this model, one of which was the harvest level we assumed into the future. In this case here, we've assumed a fixed number of animals are going to be harvested each year, and here we've specified, actually in this one, that there's no harvest, and so starting in the year 2020, which was the first year of our simulation, we specify no animals are to be harvested. If I was to open up one of the other scenarios, for example this one here, in which I have some harvest level, if I click through again to the screen where I specify the harvest levels, you'll see that the scenario is slightly different. Starting in the year 2020 and continuing forward every year after, we've told the model here that we want to harvest 2,000 animals per year. So once we've developed these scenarios, we can run them through this suite of submodels, and these scenarios actually have already been run previously, and so we can actually right-click on this, add them to the results, and look at the projections, the actual projections for each of these scenarios over time. So actually in this case, let me remove this one. Let's just start by comparing in this full version the 2 scenarios in which we have no added development, and then a second scenario in which we assume actually 10 new industrial developments across the range of the herd. Okay, and I can look at those results in this full version of the model. For example, here I can look at projection of maps, and this is one example. So for example, let's just make this a little bigger. This is one example of the kind of output that comes out of this model. So this top map, for example, refers to the no additional development, no harvest scenario, and this shows in turquoise areas in which development is projected to occur, and this actually matches current development. And down here under the second scenario where I'm showing a map projected for the additional development scenario, we can see that there are some developments that have been added by the model. And because the model is stochastic, we're uncertain to is exactly where the location of these future developments will be. So I can repeat this model several times. This is one iteration, one realization of the simulation results. If I click here, I can look at a second projection down here of where development is likely to occur. The black dots representing my simulated locations of caribou for that simulation. If I click through again, I get slightly different projection, and so on and so forth. So the idea here is that this model is stochastic, and every time we run it, we get slightly different projections of where the movement model, in this case, projects caribou will be in the future, and where development will occur as well. We could also look at other output. For example, here we can look at output now of the population model at the very end of the suite of 3 submodels. So if I right-click on that, here again for these 2 scenarios I'm comparing here, both with no harvest, one with no development and the other one with some added development in the future. You can see here in blue, this is the graph of the scenario with no added development, and we see a projection of a certain population level from the year 2020 to 2040 due to the model. And if we add some development, we see that the population projection is slightly lower. And again, this is a consequence of all the assumptions we've made throughout the chain of submodels. Now we can, because this model is stochastic, as I said before, we can get variability in these projections. So here we're showing the full range of projections surrounding each of these means over time. So this is all showing you, again, stuff that's in one of the previous videos regarding the full version of the model for software. Now what I can do is I can just put this over to one side here and open up now the simplified version. And so this is the simplified version of the CCE. You can see the screen is already considerably simpler. It's designed to be very easy to use, but we do start again in the same way where we go and we find and we open a library of model inputs and outputs. And in this case, I'm going to open the same library I have open in the full version of the model. And lo and behold, in this interface, I get the same 3 scenarios that I've been working with here. Okay, and as I can in the full version, let me just get rid of that. I can pick a couple of these scenarios. Let's take the 2 that I've been looking at so far, the no development, no harvest, and the second scenario in which I add some development on the landscape. And I can look at maps just like I could before, similar maps to what we saw before in the full version of the model. I can also look at different charts, and in this case, the one I'm most interested in is the final projection of population. So I'm getting exactly the same results out because I'm running the same scenarios and viewing them as I was in the detailed version of the model. So why have this simplified version? Well, the idea is that it's much easier for managers, for example, and people that are not detailed scientific modelers to then game with the results of this scientific model. So let's take an example here. We've got a 3rd scenario that we haven't looked at. Okay, so if I bring up all 3 of these scenarios and again look at the population, the first 2 scenarios are the ones that I showed you before. The blue is no additional development over time. The red is some additional development. And then this green one now I've added is a 3rd scenario in which I have, again, additional development, but I've now imposed a harvest level of 2,000 animals per year. And you can see the projected effect on the population. Now what I can do is, so far I'm just viewing results that were created in the detailed version of the model, but now I can come in and do some what-if scenarios about alternative harvest levels out into the future. So let's take, for example, if we just unclick these and select this last scenario in which we had a certain level of additional development and a certain level of harvest, and I can make a copy of that scenario. Okay, and the system has created a copy of it up here. Okay, and I can click on this and open up the details of that scenario. And let's suppose now I want to try increasing the harvest to say 3,000 animals per year. So I come in here and I just change the name of the scenario. So I'm 3,000, and somewhere down here in the description, I must have said that, I'm harvesting 3,000 caribou per year instead of 2,000. And now if I look at the inputs, much simpler set of inputs than in the full version of the model. All I can do actually in this version is change the duration of my simulations. Okay, I can change how many iterations or how many times I repeat it for stochastic purposes. And I can also play around with different alternative harvest strategies. So far on this screen, we've told the model that we want to specify our harvest as an absolute number of animals, and we want that harvest to start in 2020 with 2,000 animals per year and to continue at that level for the duration of the simulation. So I can come in here now and do a what-if scenario where I change this to, say, 3,000 animals. Okay, so I've made a change to that scenario. I can save that change. And you'll see here up at the top, if I resort these by clicking on this column, I now have this scenario with 2,000 animals and one with 3,000. Now you'll notice that when at 3,000 it doesn't have a little graph icon here yet, and that's because I haven't run it yet. There's no results for it. So I can check on that scenario and click the Run button and actually run the simulation through our CCE model. And again, we're using the full model. It's just a simplified interface on it. So the results have come back, and now what I can do is I can look at the results of that scenario. So I can look at the charts again, and I see that I get a different projection for the future population, and in fact it's now projecting the population will decline over time if I add these 10 new developments and raise my harvest level up to 3,000 animals per year. And if I compare that to the previous scenario, actually here the colors have changed, so the blue is now the harvest, the original one of 2,000 animals per year, and the red is this new scenario with 3,000 animals per year. So that's one example. Now I could do another analysis, so maybe I could be more sophisticated about how I choose to harvest those animals over time. So here let's take this 3,000 animal per year scenario and make a copy of it, open it, and now let's change. So far we've been taking animals directly in proportion in terms of the age and sex of the harvest in proportion to what's available in the population. But I could be more targeted. I could say choose to have a bull to cow ratio of, say, 4:1. So bull to cow ratio of 4 bulls for every cow. Okay, so that's coming up with a particular strategy where I take more bulls than cows, and to then set that up in the software. Now here, instead of just specifying 3,000 animals, I can right click here and say I want to specify these animals by sex. And so here I've added in an extra column, and I can say, okay, I actually want, of that 3,000 animals, what if I was to make 500 per year be my target for bulls, and then if I do for that same year, the first year of the simulation, I set the number of cows to be 2,500, and so basically I've set the ratio of bulls to cows to be 4 cows for every. Actually, I've done this backwards, so let's put that. I want 4 bulls for every cow, so I got it backwards, right? Okay, so that's setting up a new what-if scenario, okay, with this new title now. So I can close that. If I save my results, it'll update the title here. So I've got this new scenario now. So let's uncheck this, check this one, run this new scenario again, and now I'll show it against the harvest, same total harvest, but without this specific bull to cow ratio. Again, bring up my chart of population, and what you see here is the blue scenario is my original 3,000 animal per year harvest, again with additional development on the landscape, and this is my new scenario, which I target more bulls than cows, and the population under this harvest scenario is projected to increase. And once again, like I showed in the detailed model, there's variability around these projections due to some of the uncertainty in my model inputs. So that's a brief introduction to the simplified version of the CCE, or Caribou Cumulative Effects model. If you want to get more information on the model, you can go to our website, apexrms.com. If you just scroll down on the home page, there's a project called Caribou Simulation Model. If you click on the details, you'll get a little bit more information about the project and how to get hold of the software. Okay, thanks for listening. Have a good day.